Welcome back to Space and Mystery. Today, we're exploring some of the most fascinating types of stars you'll find in the universe. From main sequence stars like our Sun to the colossal red giants and the compact fading white dwarfs, each type of star is unique in its life cycle and characteristics. So let's dive in. Let's start with main sequence stars. When people think of stars, they're often picturing a main sequence star like our Sun. These stars are in the longest and most stable phase of their lives, spending billions of years fusing hydrogen into helium in their cores. Main sequence stars come in a variety of colors and sizes. The larger, hotter stars tend to be bluish and shine much more brightly than smaller, cooler stars, which appear reddish. The color of a star tells us a lot about its temperature and size. Blue stars are the hottest, while red stars are cooler. Our Sun is a yellow dwarf, a fairly average main sequence star in terms of size and temperature. But main sequence stars can range from tiny red dwarfs, which are much cooler and live for trillions of years, to massive blue giants that burn brightly and exhaust their fuel within a few million years. Next up, we have red giants. This phase marks the end of a star's time on the main sequence. When a star like our Sun runs out of hydrogen fuel, it starts fusing helium and other elements in its core. The outer layers of the star expand and it becomes a massive, cool star with a deep red or orange glow. Red giants are huge, often hundreds of times larger than they were on the main sequence. But despite their size, they're relatively cool on the surface, giving them that signature red color. Our Sun will eventually become a red giant, expanding and engulfing the inner planets, including possibly Earth. After spending a few million years as a red giant, the star will shed its outer layers into space, creating a beautiful structure called a planetary nebula. What's left behind is the star's dense core, which brings us to our next type of star. After a star sheds its outer layers, it leaves behind a white dwarf, a dense, dim core about the size of Earth. White dwarfs are what's left after medium and low-mass stars like our Sun have used up all their fuel. These stars no longer undergo fusion, so they don't produce any new energy. A white dwarf is incredibly dense. 1 teaspoon of white dwarf material would weigh as much as a car. It shines faintly with leftover heat, but will slowly cool and fade over billions of years, eventually becoming a cold, dark remnant known as a black dwarf, although that phase takes longer than the current age of the universe. White dwarfs are a fascinating glimpse into the final stages of a star's life. They're reminders of the powerful processes that shape stars, and even after fusion stops, they continue to glow dimly for a very long time. While today we're focusing on main sequence stars, red giants and white dwarfs, it's worth mentioning that larger stars end their lives a bit differently. High-mass stars can go supernova, leaving behind neutron stars or even black holes. These end states are just as fascinating and are a part of the larger story of star evolution. Studying different types of stars helps us understand the universe's history and our own solar system's evolution. Each star type, from main sequence stars to red giants and white dwarfs, tells us something unique about stellar lifetimes, element creation, and cosmic cycles. To recap, main sequence stars like our Sun spend most of their lives fusing hydrogen. Once they run out of fuel, they become red giants, expanding and eventually shedding their outer layers. What's left is a white dwarf, a small, dense core that slowly fades over billions of years. Each type is a chapter in a star's incredible journey. Thanks for watching. If you enjoyed this breakdown of star types, hit the like button and subscribe to Space and Mystery for more content about the cosmos. Have questions about stars or the universe? Drop them in the comments below and we'll see you next time.